Hey everyone! So our next topic is the GOES Lightning Mapper, or GLM. To get recent lightning data, go to the Satellite and Radar section of the Data Chooser. You can either click on the GLM button here, or you can go directly to the GLM Data Chooser using the sidebar. There are a few options here. The first is which data server you want to use. Unidata's ADDE server is generally a good bet. Then you have to choose the group. On this server, the options are real-time data from a GOES-R satellite or real-time data from a GOES-S satellite. Once you have the server settings, you can go ahead and connect. Some networks will block this connection. If yours is one of these, look for the upcoming ADDE Port 80 video in the IDV Advanced Topics series, or if you need to know the workaround before that video comes out, write to us at support-idv@unidata.ucar.edu. After connecting, you'll have to pick a GLM type. This part can be a bit confusing if you don't have a lot of experience working with lightning data, so I looked up this flyer online that explains the different options pretty well. The GLM defines an event as an occurrence of a single pixel exceeding the detection threshold during one frame. In layman's terms, this means that an event is a tiny speck of lightning. A group is a collection of simultaneous events close to each other, which would be one main branch of lightning if you were looking at it from the ground. A flash is a collection of groups close to each other in time and space. This would correspond to a lightning bolt. If each colored dot in this diagram is an event, then each of the smaller dashed ovals would be a group. The squares represent pixels. The GLM doesn't record exactly where within a pixel each event was, but it did recognize events in the lighter pixels. The red, blue, and green groups make up one flash. Now that we know what the options are, we can pick a GLM type. Flashes are probably the best to plot over a large domain. There are also a few time options that we need to specify. The first is the list of times to be used. There are two ways of specifying times, relative and absolute. Relative will let you retrieve near real-time data that updates automatically. Absolute will ensure that your data doesn't update until you're done working on it. The lightning data shows up best on the map if you make a point data plot. You can pick the icon to show at each data point. Fade by time lets you see multiple time steps in each frame and tell which flashes belong to which time steps. To take advantage of this, we should show multiple time steps per frame. Right now, the IDV takes quite a while to plot GLM data. This is because the GLM uses a timescale on the order of milliseconds, and each time step is stored in a separate data file. The IDV has to condense all of the files for your time step into a single display every time a display is created. In the future, Unidata plans to pre-process GLM data and publish it with longer time steps. This will remove a significant amount of the data processing from your computer so that you can generate figures faster. Decluttering hides some of the data so that you can see at least some of the individual data points instead of blobs of data points. There's a significant difference between high density and no decluttering. To see near real-time data, you can turn on polling. In the field selector, find your data source and double-click on it to open the properties. Click on the checkbox and specify how often the data should be reloaded. This is also where you can change the length of each time step, which is called bin size here. You are still limited to the number of time steps that you specified when you originally created the data source, but you can change almost any other property here. Each flash can also be described by parameters besides location. You can find a detailed description of the units and derivation of each parameter by following the link that I put in the description of this video. There are a few things that you can do with these fields. The most obvious is to plot them. I haven't shown you the Hofmahler display yet, so let's make one now. Everything's pretty much the same color, which kind of defeats the purpose of setting the color based on the energy intensity. To make the plot more useful, you may have to play around with the bounds of the color bar for a while. Another really useful thing that you can do with the gridded fields parameters is you can filter the point data. We can plot all of the flashes that have positive energy, or we can plot all of the flashes with energy greater than 1,000 microjoules per steradian per meter squared per micrometer. Now you know why I sent you to a paper for the units rather than explaining all of them myself. As I mentioned before, the GLM stands for Geostationary Lightning Mapper. It doesn't just give you information on where the lightning is, it can show you information about its path. The dataset that I have loaded now isn't the same one that I had loaded earlier. I'm recording on a different day. We're going to add all three GLM categories to one map. Events can be first. I want an extremely small time step so that we don't have to worry about data points being hidden by the decluttering algorithm or overlapping excessively. We'll put the events on the map and then add the groups. These look just like the events, so we'll change the symbol. After plotting and changing the symbol for flashes, we can explore the data. I'm going to look for a good example in the Caribbean area. This cluster in Florida looks promising. After zooming in, we can see that the events are the most widely spread, followed by the groups. Events are great if you want an idea of the lightning's extent. If you're making the call on whether or not to delay the soccer game, the events are your best indicator of where the dangerous areas are. If you're comparing GLM data to surface station lightning data, you'll want to use the groups. They're the most similar to what most ground stations will detect. Lots of flashes can indicate strong updrafts. They could be useful if you're studying the relationship between lightning and storm strength. With this information under your belt, you should be ready to start using the GLM data in the IDV on your own. If you have any questions, visit our website at unidata.ucar.edu or email us at support-idv@unidata.ucar.edu.